I hope you're having a great day. I got this radical equation from a subscription of mine, Pre-Math. I see a lot of his problems from time to time that are somewhat challenging, so I want to go over my version of its solution. You have the square root of quantity 2x plus 1 equals 4 minus the square root of quantity x minus 3. And what we're going to do is just work toward solving it. And the first thing I'm going to do is add square root of quantity x minus 3 to both sides of the equation. And when we do that, we get 4 is equal to the square root of quantity 2x plus 1 plus the square root of quantity x minus 3. Now what we're going to do is square both sides of this equation. So on the left side we have 4 squared, and on the right side we wrap both of those radical expressions in parentheses and square them. And so now on the left side, 4 squared is 16, and on the right side what we have is the first term squared, so we have the square root of quantity 2x plus 1 squared, and then we have plus 2 times the first term and the last term, so that's going to be 2 times the square root of quantity 2x plus 1 times the square root of quantity x minus 3, and then finally we have plus the square root of quantity x minus 3 squared. And what we've done here is simply a 1-to-1 binomial expansion of the form. Let me see. If we have a quantity a plus b squared, that is going to be a squared plus 2ab plus b squared. And so that's all we did here. And next we're going to continue writing down here 16 equals, and on this first expression here that I'm circling, the square root and squared cancel each other, so we have 2x plus 1, and then we have plus 2. We just bring down this 2 times quantity 2x plus 1 times quantity x minus 3, and squaring here on the last term, what we have is plus x minus 3. So really that's what we have here. Now we're going to collect the like terms, and so on the left side we have 16, and the right side we have 2x plus x, that's going to be 3x, and we have 1 minus 3 or minus 2, and then we have plus 2 times quantity 2x plus 1 times quantity x minus 3. Okay, the next thing we're going to do is add 2 to both sides of the equation. So now on the left side we have 18, and that's equal to 3x plus 2 times quantity 2x plus 1 times quantity x minus 3. Okay, the next thing we're going to do is simplify by dividing both sides of this equation by 2. And what that's going to do on the right side is that 2 over 2 is going to cancel each other. So on the left side, now we have 9 equals 3/2 x plus square root of quantity 2x plus 1 times quantity x minus 3. Okay, the next thing we're going to do is take this 3/2 x and subtract it from both sides of the equation. So now what we have on the left side is 9 minus, let's see, 9 minus there we go, 3/2 x equals the square root of quantity 2x plus 1 times square root of quantity x minus 3. Okay, what we still have now is a radical on the right side, so we're going to, again as we did earlier, square both sides of this equation. And when we do that, we get on the left side 81 minus, we're going to have 2 times 9. I'm going to work this on the upper right. So we're going to have 2 times 9 times negative 3/2 x. And what is that going to be? Well, the 2 over 2 will cancel each other. And so what we have is negative 27x. So I'll put minus 27x. And then we're going to have 3, this negative 3/2 squared is going to be plus 9/4 x squared. And the right side, what we have that equal to is squaring everything. We're going to have quantity 2x plus 1 times quantity x minus 3. Okay, let's go ahead here and I'm just going to write down the left side 81 minus 27 x plus 9/4 x squared, and on the right side we have 2x times x, or 2x squared, and then we have the middle term plus 1x minus 2 times 2x times 3. It's going to be minus 5x, and then we're going to have negative 3 times 1, which is going to be negative 3. And so now I'm going to bring this way up here. I'm drawing this right up here. I'm going to work down from where I've arrowed over, and I'm going to just rewrite this. 81 minus 27x plus 9/4 x squared is going to be equal to 2x squared minus 5x minus 3. And so what we're going to do now is subtract 2x squared, add 5x, and add 3. And on the left side, we're going to do the same thing, subtract 2x squared. We're going to add 5x, and we're going to add 3. And then on the right side we have now 0, and on the left side we have 9/4 x squared minus 2x squared is going to be 1/4 x squared, and negative 27x plus 5x is going to be negative 22x, and then we have 81 plus 3 is going to be plus 84. And now we have 1/4 x squared. What I'm going to do is multiply this whole equation by 4, and what we get now is 1/4 of 4 is 1, so we're going to get x squared, and then 4 times negative 22x is going to be negative 88x, and then 4 times 84 is going to be, what is that, 336. And that's going to be equal to 0. So now we have a quadratic equation that I hope we can solve. And what we're looking for now are the two numbers which, when multiplied together, equal 336, yet when added together equal 88. So we see they're going to be pretty far apart, and so we can rewrite 336 is going to be equal to 2 times half of 336, which is going to be 168. And if we factor 168, we will have, let me write this down here. We can write this as 2 times 2 times half of 168, which is 84. And then we can combine these 2 times 2. We're going to have 4 times 84 is going to be equal to 336. So what we have for our factoring is this. We have x minus 4 times quantity x minus 84 are equal to 0. And then using the zero factor property or zero product property, we know that x minus 4 is equal to 0, and likewise x minus 84 is equal to 0. So x is going to be equal to 4, and also x is equal to 84. So now we have our solutions. The only thing left to do is to try our solutions out on the original equation to see if they are real solutions. So if we plug in 4 to our original equation up here in the upper left, we have 2 times 4, which is 8, plus 1 is 9, and square root of 9 is 3. So now on the left side we have 3, and the right side we have 4 minus the square root of 4 minus 3, so 4 minus 1. So we have 3 equals 3. So this right here, x equals 4, this is a verified real solution. Now for 84, if we plug that into the original equation, we have 2 times 84, which is 168. 168 plus 1 is 169. Square root of 169 is 13. So we have on the left side 13, and the right side we have 4 minus, well, we have 84 minus 3 is 81, and the square root of 81 is 9. So we end up with 13 equals 4 minus 9, which is not a solution. So this right here, x equals 84, we call this an extraneous solution. And an extraneous solution is a solution that's created in the process of solving a problem. It happens sometimes, as in this case, for radical equations, sometimes for rational equations, and sometimes for logarithmic equations. And as you can see here is that we have 13 equals 4 minus 9. Well, if that were instead 4 plus 9, that would be a real solution. So anyway, that's it. I hope this has been a helpful exercise for you. You learned something from it. Good luck, and thanks for viewing.